Here we are, Math 1 story problems to table graph equations. So we've got some problems here. We are going to write their tables, their graphs, look at the starting point, the growth, and write an equation. So the thing to remember here is that for a table, your starting point is always going to be 0, and then whatever number in the output. That's your starting point. Okay? And we see the growth as we go down the input and the output, right? The input here on the left, output on the right. Often we call it the x and the y. Okay, so we'll see the growth there. For a graph, on the y-axis is where we see the starting point. And then as we go in a pattern from point to point, that's where we see the growth. For an equation, we go y equals our starting point, and then we have our growth, added, subtracted, multiplied, divided, with the variable. Okay? So, that's kind of what we're looking at here. So, first we need to find those two pieces of information. So let's take a look at the first situation. A gear on a machine turns at a rate of 1/2 revolution per second. Let x equal time in seconds and y equal number of revolutions. Okay? So they kind of told us they want this to be seconds and the number of revolutions here. Now, that kind of told us what the two connections are. So what would be our starting point? Before the gear on a machine turns, we haven't revolved at all, have we? So our starting point would be 0. How is it growing? Well, it's growing at 1/2 of a revolution per second, or we could think of that as 1 revolution every 2 seconds. Okay, same concept, right? So for our table, we start out and it hasn't moved at all. After the first second, we're halfway through, right? After the second, we would add another 1/2, right? We're adding that growth each time. Okay, or 0.5, you could think of it as 0.5. So 3, 4, 5, 6, 7 seconds. At second 3, we'd have 1.5. I'm going to put 1.5. 4 seconds, we'd have 2 revolutions. 5 seconds, 2.5. 6 seconds, 3 revolutions, and so on. So we can see we're adding 1/2. Or we could actually make a table like this, 0, 2, 4, 6, because we said for every 2 seconds we'd have 1 revolution. So if we're adding 2 on the left side, we could be adding 1 on the right side. Oops, I started at 1, not at 0, didn't I? So for that fraction, you can think of it this way, okay, and the growth would be this over this, or you can think of it as this over 1. 1/2 over 1 is 1/2, or 1 over 2 is still 1/2. Okay, so there's how we see it in a table. In a graph, we start at 0 on the y-axis. There's our starting point, and I was a little off on that starting point, wasn't I? So then we would go for every second here, we'd go to the right one, right? And then we would go up. Y would be the revolutions, so we'd go up 1/2. So I'd go to the right one and up 1/2, to the right one, up 1/2, to the right one, up 1/2, and so on, and keep going. Okay, so if we look at that, our growth here from 0, just like here, 0 to 1/2, as we go over 1, we go up 1/2. Okay, as we go down 1, we go up 1/2. As we go over 2, we go up 1/2. Okay, same thing, over 2, up 1/2. And we just keep going like that. And keep going. Okay, so we should be able to see the growth as we go to the right and up, and we see the starting point right there. Now for our equation, we'd go y equals our starting point, which was 0. What are we doing to 0? We're adding 1/2, or we're adding 1 every 2. So we'd add 1/2. How many times are we going to keep adding it? we're just going to keep adding it, so we times it by x. Now, because it's plus 0, we know that doesn't do anything, so I could just turn that into 1/2 x. That's the same thing. Alright, so there's our first one. Let's take a look at the second one now. The formula for converting temperature from degrees Fahrenheit to degrees Celsius is linear. To convert from Fahrenheit to Celsius, subtract 32 from the Fahrenheit temperature and then multiply by a rate of 5/9. Okay, so looking at this, we've got to figure out, okay, we're dealing with degrees, right? We want to change it from Fahrenheit to Celsius. Okay, so that's essentially what we're looking at here. So we've got Fahrenheit and we've got Celsius here. So it says to convert from Fahrenheit to Celsius, subtract 32 from the Fahrenheit temperature and then multiply by a rate of 5/9. Okay, so we have the Fahrenheit temperature minus 32, and we take that and we multiply by 5/9. Okay, so, and that's going to equal Celsius. So Celsius is like y. Okay, so I'm writing the equation on this one because it's basically giving it to us right here. So then f would be x. So 5/9 times x would be x minus 5/9 times 32. Okay, so bust out a calculator. Grabbing one right now. So I go 5/9 times 32. That gives me 160 over 9, okay, which is not going to be helpful. So about 17.8. Okay. So where would our starting point be? It'd be 17.8. Okay. Actually, because it's minus, it'd be negative 17.8. What would our growth be? It'd be 5 over 9. Okay. So there's two ways to think about this. Okay. You could say we would be adding 5 over 9 each time. Or, because we can split up a fractional growth slope to be the y over the x, we could say we're adding 5 every time over here we're adding 9. It's almost easier in this case, isn't it? So we'd have 0, negative 17.5, or 8. Okay, then I'd have 9, and then 18, and so on. Or I guess I could even go negatives, couldn't we? Now here's something to notice. Okay, let's say I made this 0, and this was negative 17.8. Okay, that's still, even if I go back to negatives or to positives, okay, even though I've got this is not my starting. My starting is always where the input is 0 and the output number is, okay? So then we'd go negative 17.8 plus 5 to get negative 12.8 plus 5 more to get negative 7.8 to get negative 2.8 and to get a positive 2.2. Okay, and if I'm going the other way, okay, what number plus 5 would give us negative 17? Oh crap, I did something wrong, didn't I? I can't count by 1s on that side, can I? To count by 9s. Negative 9, negative 18, negative 27, 9, 18, 27, 36. There we go. That looks much better. Okay, so now I'm using my growth and my starting point, okay, to finish my table. So negative 17.8, I'd have to subtract 5 to go backwards. That'd be negative 22.8, negative 27.8, negative 32.8. Okay, so that table's kind of ugly, but that's how we could use it. So then graphing, we'd start at negative 17.8, right, again. So let's make this, let's count by 2s here, so negative 20, 16, 12, 8, 4. so on. Okay, and we'd have a 0, negative 17.8, so like right about there. Okay, now my growth is I'm adding 5 every time I add 9. So every time I add 9, I'd go over here to 9. Okay, so this would have to go clear over to 9. It's going to jump up 5. Okay, so it would jump up 1, 2, 3, 4, 5. Right, it's negative 7.8. So right there. Maybe not right there. There we go. So then I can draw my graph. What the? I did not mean to do that little bump there. Okay. So it would look something like this. Okay. That was kind of a tough one because we were dealing with some ugly fractions there. Alright, let's try the next one. A limousine company charges an initial rate of $50 and $75 for each hour. Okay. So we're talking about how much they're charging, right? That's one of our groups. And how do we know how much they're charging? Well, every hour. So that's our second group. So the hour is going to affect how much they're charged. So what would be our starting point? Well, they say they charge an initial rate of 50, so our starting point is 50. 50. Let's count by tens here. 50. Okay. So y equals 50. See how that starting point affects everything? Now what's our growth? Well, 75 for hours. So we're adding 75 for every hour we add. So 1, 2, 3, 4, and so on. Okay, plus 75. 50 plus 75 is 125. Add 75 again. We get 200. Then 275. Okay. 350. 425. 500. 570. Okay. So how would we do that to our equation? Well, we'd add 75, and we're going to keep adding 75, so we times it by x. Now, could you rewrite this as y equals 75x plus 50? Because it's positive 50? Yeah, you could. Okay, so here we're going to have to go up 75. So we count up 1, 2, 3, 4, 5, 6, 7. That'd be like 75 to the one right. Okay, so something like that. And then we'd go up 75 and to the right 1 again to get our equation. If you really wanted to, you could redo this as your x and y intercept. So then count by tens. That would be 50. That would be 100. 150. 200. And then you could, make that your y-intercept. Then we go to the right one and up 75 to right about there. And then you'd go up again to the right one and up again. So you could do it like that. If you need to adjust that graph as needed. Okay. Alright, let's take a look at the next one. Oops, which is down here actually. Okay, Angela receives a base salary, weekly salary of $100 plus a commission of $65 for each computer she installs. Okay, so we're talking about her salary, but what's her salary based on? Well, you might want to say weeks, but it's actually this commission. Remember, a commission is every time she installs a computer, she makes that much more. So the more computers she installs, the more money she makes, so it would be computer installs. So this would be our computer installs. This would be her salary. So where does she start? Well, if she doesn't install any computers, she'll still make $100. That's her starting point. So on a table, what does that look like? Well, no computer installs, she still gets $100. On an equation, what does that look like? Y equals 100. Okay, that's what she gets no matter what. What would it look like on our graph? Okay, so this time I'm going to make this my y-axis. So that's her salary. This is my x-axis, her computer installs. Okay, let's count by 50. So that would be 100, 200, 300, 400, 500. Okay? So we would start out at 100 again. Okay, so there's our starting point for each one. Now, how is it growing? Well, she gets a commission of $65, so for every computer, so as this goes up by a computer install, this is going up by $65. Okay, so we just keep going. Get 230 plus 65, 295 plus 65 would give us 360, then 425, then 490, and 555, and so on, right? So there's our growth, 65 over 1. $65 for every computer install. So we take that 100 and we add 65 to it. Okay, and we're going to keep adding 65 till we get down to x, so we times 65 by x. So where do we see that on our graph? Well, for every computer, every time we go 1, we're going to go up 65. Every time a computer goes 1, we're going to go up 65. Computer goes 1 more computer install, we go up 65 more. Okay, so it'll just keep going at that rate. Looks something like that. Okay, there we go, guys, on that one. Okay, next one. A cable company charges a monthly fee of $59 plus $8 for each on-demand movie watched. Really should have printed out better graphs for you guys, huh? Okay, so how is our monthly fee charged? Well, it's $59 to start with, right? There's our starting number. And then how is it going to grow? Well, it's 8 for each on-demand movie watched. So we're going to grow by $8, depending on what? How many movies we watch. That's going to tell us the cost. So our starting number before we watch any on-demand movies is 59, right? Okay. Then after we watch our first movie, we're adding $8 for every movie we add. So we'd get 67. Then 75 for the second. Then for the third movie, 83. Then 91 for the fourth. For the fifth, 99. For the sixth, 107. Apparently I can't make these videos when bells are going on. Okay, then the last one, 115. Okay, and there's our table. Okay, so then when we graph it, we have our starting point at 59. Okay, so here we'll count by 2s probably would be good. So no, 2 won't get me high enough, will it? Let's count by 5s. So it'd be 5, 10, 15, 20, 25, 30, 35, 40, and 50, then 60, 70, 80, 90, and 100. Okay, so we start at 59, which would be right about there. And then we're going to, every time we go to the right one, right? Every time we watch another movie, we're going up $8 more. So it'd be to 67. The next time we watch a movie, up more to 75. Watch another movie, up to 83, then 91, and so on like that. Okay? Now with our equation, right, we go y equals our starting number, 59. What are we doing? We're adding 8. How many times are we going to add 8? We'll keep going down until we get to the variable, so times it by x. So hopefully you're noticing those numbers, starting, 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 and also the growth, the growth, the growth, the growth. Okay? 6. Garrett borrowed $500 from his aunt. She doesn't charge any interest, and he makes $15 payments each month. Okay, so once again, I suck at giving you guys good graphs to work with. So we'll make this 500. Okay, which means this would be 250. Which means we're counting by 25s. So there's just some reference points. To give us an idea. Okay, so we're talking about how much Garrett owes, right? And how much he owes is going to get less and less each month, right? So when we start our first month, he owes $500, right? So there's our starting number. There's our starting number. Y equals our starting number. Okay? Then he's making $15 payments each month. So we're subtracting 15, right? Because he's paying it off. And we're going off how much he still owes. So after the first month, we've subtracted $15, right? So we end up with $485. We go the next month, and now he's down to $470. Then it's $455 after 3 months, right? So we're subtracting 15 each time. Okay, so every time we go to the right, we have to go down by 15. Every time we go for 1 month, we're going down 15. So 440, 425, 410, 395 as we go down to finish our table. Once we got the pattern, it's pretty easy, right? Okay, so the equation, we're subtracting 15 each time, and we'd multiply that by our variable. So for our graph, going down 15 wouldn't quite be all the way down there for every time we go to the 1. So it's going to look something like this. And at 5, we should be to 425. Okay, so I actually probably need to make it a little smaller. Something like that. Alright? Okay. Last ones. A small newspaper company is downsizing and has lost employees at a steady rate. 12 months ago, they had 65 employees, and now they have 29. Alright, so this one's kind of trickier, right? So what would be our starting point? Would we say 65 or would we say 29? Well, it said 12 months ago, so now that we're starting right now, technically we should probably call this 29. Okay? And the way to think about that is like this. Okay? So if we start at 0, we have 29. And we've got to make our way back to negative 12 months. Okay? So that was at 65. So in 12 months, how many have they lost each time? Okay. Well, in 12 months, if we go 65 minus 29, we'd end up with 36. So in 12 months, they've lost 36 people. So can we split that up into 12s? Okay. 36 would be split into 3 12s, right? So every month, we'd be losing 3 people. Okay, so that's our growth. We're subtracting 3 each month. Now, could we go back and get our table up to negative 12? Yeah, we could. But now that we know that we're subtracting for every month, that would be 26, 23, 20, 17, and so on. Okay? So our equation would be y equals 29 minus 3 employees each month. So for our equation, we need to start up at 29. Okay, so if we counted by threes, that would be 30. That would be 15, 0. Once again, we'll make this our y axis, this our x. So we start out at 29, and every month we go down by 3. So it'd be 26. Okay, actually, if we're counting by threes, it'd always be right below there, and it'd look something like this. Every time we go down 3, we go to the right one. Down 3. Every month we go down 3. Okay, and we just keep going like that. Alrighty. Now, last question: what is the importance of the starting number, y-intercept, and the slope growth? Tell how they are each used for the table. Okay, that helps us know where we're starting, obviously. Okay, and it gives us a good place to start our pattern. The slope and growth then tells us the pattern. Okay. So using that pattern applied to the starting number is how we figure out what's going on. Okay. I guess I should say how we use that slope growth is telling us what our pattern is. So how do we use it in the table? Well, the starting number, right, always goes right there. The growth tells us how we go down our table on both sides, doesn't it? Okay. On a graph, the starting number is somewhere here on this y-axis, right? Okay, the growth tells us how far we go this way or up and down. Okay, that growth is what determines where we go from point to point, using that kind of stair-stepper method. And finally, the equation. If we think about that y equals mx plus b, our starting number, which we like to write it like this way, that starting number kind of shows us how it affects our whole overall answer, but it's just a one time. Okay, and then the slope here with the x tells us how it's growing, and it's the number that goes with x. Alright, there we go, guys.